Hi everyone. So in this lecture, we are going to talk about what do we do before we start analyzing the data. So I'm sure by now you all have downloaded the NSCH dataset, and when you download that dataset, you see a zip file which contains of all these documents, and within those documents along with the SAS codebook you also see a file of SAS formats and the actual data set, which is the 2019 data set. So in order to open the data set in SAS, we need to first run these formats. So what I've done is I've simply copy pasted them into another SAS document, and I have created a library name over here by copy pasting the path where I have stored my SAS data set on my personal computer. So what I'm going to do here is I'm going to simply do Control A, and I'm going to run this entire code, and you will see that the entire format for this particular data set runs, and there are no errors right now seen in the log, and you will see a NSCH library that is created over here, and this is the data set that we downloaded, and now we can open it in SAS. So even before we start playing around with the data or manipulating the data, it's always advisable that we create a subset of the data. So to create a subset of the data, what I'm going to do here is I'm going to create a new file by the name of NSCH, and I'm going to subset it using the particular library name which we created, and this is the document which we downloaded. So when I run this, you will see that SAS will tell us that there were these many observations read, and if we go back and now look in the work folder, this exact same document has been replicated with a new name, and we can now start working on that particular document and manipulate this data set. So to begin with, we have to begin with a research question. So over here I have formulated one research question, which is, does school lunch program lead to increased weight or obesity in children, or we can also say in school children? So this way we can create a research question. Now from this research question, we have to identify the keywords. So the keywords over here is obviously the school lunch program and obesity or overweight. So lunch program or free lunch becomes the exposure variable over here, whereas obesity or overweight becomes the outcome variable. So the way to now go ahead and critically evaluate the data is to look at all the variables that are available in the data set. And the best way to do that is to run proc contents. And when you run proc contents, it shows you all the variables that are available in the data, and then we can go through each one of them and we can actually see which variables we would like to work with. And the beauty of this is that we can look at them alphabetically, and you can see there are various variables starting with data on adult variables, and if we keep scrolling down, there are other variables such as allergies, ADHD. So what I did was I evaluated this particular proc content, and I saw which variables I want to work with using this particular research question. And then again, as we think about confounders, we have to start thinking about which other variables could potentially affect the exposure and the outcome. And there are several uh, variables in this data set which are related to food or food assistance. So we can take those variables also into consideration when we are doing our analysis. So as you can see, one variable over here is food situation in the household. And similar to this, there are several other variables which are included in this data set. So looking at all those variables, what we can do further is we can actually compile a data dictionary, which you can see on the screen right now, which includes all the socio-demographic variables along with the exposure and outcome variables. So as we start thinking more about this question, we have to think about which of the variables are closely related to the exposure and the outcome, or which of the variables could act as a proxy for the exposure as well as the outcome. So BMI is one variable which is closely related to the outcome, and it is in some way related to our exposure also, because whatever food the school children are going to eat is going to have an effect on their BMI, and then BMI is used to see if there is obesity or overweight in children or not. So this way we have to do some kind of critical thinking and evaluation of the data set, and we can prepare a data dictionary which can be prepared in a Word document, or you're free to use Excel also to prepare a data dictionary. Over here, I have chosen to just include three columns: variable, variable indicator, and the actual question. If you wish, you can create a fourth column and also write the options, which is the responses 1, 2, 3, 4, and what those responses were. So this data dictionary will be helpful for us as we go on to see what else can be explored in this particular data related to the research question that we have come up with. So now again, coming back to SAS, whenever we do exploratory analysis, we can simply run some frequencies just to see the distribution of that particular variable. So I'm sure you all have learned this in SAS, and how to run frequencies. And now if I simply run this frequency, you will see that it gives me the number of children who were identified by their doctor as overweight, where 1 is yes and 2 is no, and there is a missing frequency of 110. And in addition, if we want to see how we can actually do chi-square test also. So since this is a survey data, so instead of using proc-freq, what we can use is proc survey freq. That can also be used in this particular data set because it is a survey data. So survey freq procedure is applicable over here, and then we can simply write the same variable, which is overweight, and along with that we can put a forward slash, and we can write that we just want to see the row percentage and we want to see the chi-square, and this becomes a proc survey freq coding or data. And over here you see that now we get the p-value, and whenever we look at the output, we have to look at the p-value over here along with the percentages that it gives us. So this way we can do some exploratory analysis going forward, not only with the exposure and the outcome, but also with the demographic variables. Now, when it comes to demographic variables, we can also use proc univariate. So proc univariate is a procedure which is used to see how histograms can be created, and these are very basic procedures. I'm sure most of you are familiar with it, but this is just an example to show you how we can run frequencies and procedures, and we can actually see the distribution of each of the variable that we are interested in looking at. So over here, I'm taking an example of a continuous variable. Whenever we are running histograms, it's recommended that we run them using continuous variables, and this is a age variable, and as you can see, it has a bell-shaped curve. Okay, if we run a line on top of each of these bars, it will turn into a bell-shaped curve. So it means this is a pretty normally distributed data of age in years of adults in the household where the children live. So this way we can go ahead and we can run some frequencies to see the distribution of the exposure and the outcome. And other than that, we can also run some frequencies on demographic. So whenever we are doing any kind of descriptive analysis, then we can use comments. It's always recommended that we use comments, and we can go ahead and run frequencies of all the demographic variables that we wish to include in our particular data. Now over here I have included the categorical age variable, the gender, this is race ethnicity variable, this is the language spoken at home. This may or may not have an effect on the exposure and outcome, but I still want to keep this, and then as I go further in my analysis, I will decide if I want to keep this variable or do I want to delete this variable. This is the federal poverty level. So the amount of income in the household can definitely have an effect on the food habits, school lunch, the school that the child goes to, and the obesity in the child. And this is adult education in home. So the amount of education the adults have in the home can to some extent influence the food habits, and this I'm just keeping it as an option to see if it actually has an effect or not. And then again, if you simply run this, it will give you frequencies along with the chi-square and the p-value. So this way we can run the same table for demographic or descriptive variables also. Now in the last class I talked about recoding variables. Now when it comes to recoding variables, we should always look for what the actual original variable is, and then decide if we want to recode this variable or not. So one example I'm going to show you here is the variable which is called the health status. So in this question, this variable denotes health status, and over here what I can do is I can again subset the data, because we are going to create a new variable, and along with that what I'm going to do is I am going to actually write the name of the variable, and the name of the variable is K2Q01. Okay, so this is the name of the variable. But even before I go ahead and recode this variable, let me first see how is the distribution of this variable. So what I'm going to do is I'm going to simply replace it in this statement above. And remember, this is a categorical variable, but I would still like to see the distribution of this variable. Now, when you look at the distribution of this variable, you can see that this is actually not a bell-shaped curve. Although this is a categorical variable, but still we can see that it is a skewed data, and it is skewed to the left with most of the data concentrated in the first category, which is child having excellent health, and very minimal data in the poor category, which is child having poor health. So in this case, if we want to recode this data, we can definitely recode this data, wherein we can say that we want to club a child with excellent health, very good health, and good health into one, and child having fair health and poor health as having poor health. So your one category becomes good or excellent health, and your two category becomes having poor health. So you can have a binary outcome instead of having this summary variable wherein you have categories of 1 to 5. So when we are doing that, what we can do is we can subset this particular data and recode this variable, wherein we can write that if this particular variable is equal to 1, then general health status, you can give it whatever name you like, is equal to 1, and in our case 1 is equal to good health. And now we know that this particular variable has been divided into 5 categories. So instead of having to write 5 lines, what we can also do is we can write this code in this particular way, wherein we don't have to write each line every time, and we are just telling SAS that if this particular variable is equal to 2 or 3, then create a general health status variable which is equal to 1. Okay, and then again for the rest of the category we can do the same thing, and instead of typing, what you can do is you can just copy paste what we wrote previously and then paste it here, but make sure that you change the 2 and 3 to 4 and 5, and over here change this 1 to 0, because 0 means they did not have a good general health status. Else, if it is not equal to any number between 1 to 5, then this variable should be equal to missing, and this is how we can actually recode the original variable. And now if I run this, you will see that in the log there are 840 variables. So previously when we subsetted the data, we saw that there were a total of 839 variables, as you can see over here. And now that we have created one more variable, this variable has turned into 840, the total number of variables. Now, if we want to see this new variable in our data set, then we can open the data set, and all the new variables that are created are always put at the end of the data. So you can see now instead of 1, 2, 3, 4, 5, there is only 1, and you can see that there was also 0 over here, and then if it is not between 1 to 5, then it was missing. So this is how we created a new variable. So this is what is known as recoding variables, and kind of preparing the data or cleaning the data. Whether you want to recode this variable or not is completely up to you, depending on what you're going to look at. Whether you want to delete the missing or impute the missing is also completely up to the researcher, as long as you feel that it's not going to actually bias your outcome or affect your outcome. So when it comes to missing variable, I would like to show you one more variable, which is BMI class. And this particular variable actually has a lot of missing data. So if I type in BMI class over here and run this, Then in the frequency, you will see that it has 14,432 missing, which is almost 50% of the data is missing. And you will also see that over here, it shows character variable because I have actually not recoded this variable, and I have also not used the format. I have used the actual variable. So in this case, whenever there is such a large percentage of missing variable, it's completely up to the researcher if you want to drop it from the analysis. But if BMI class is going to be your outcome, then whenever you compute your analysis, your total N will change from 29,433 to 15,001. So it's up to you how you want to subset the data and analyze the data. So these are just a few steps to show you how you can clean the data and prep the data. And always don't forget to subset the data before you start actually analyzing it. So in the next class, I will talk a little bit about how to write the results section, and then we will run some codes on linear regression and logistic regression. So that will be it for this class. Thank you.